Hi grade 9s, we are on the Unit 3 Day 4 lesson, and we're going to extend what we did in the previous few days with solving equations to look at more complex equations that we're going to be able to solve even if there's fractions in our equations. So all of today's are going to be particular examples of polynomial equations where we may have to collect like terms or multiply by a monomial, but also where these are going to contain fractions. So we're going to look at a few different techniques. Okay, the first example, and we've got kind of step-by-step notes on each one. Of course, you guys know that these will be posted with the link to the images on the outline, so you can always go back and read through the notes that are posted up there if you don't catch something in the video. So the first example is basically what we did before with the method of multiplying everything by the lowest common denominator. So when we do this, when we have polynomials though, we're going to have to put that binomial, usually it's a binomial, that's on the numerator or on the top of the fraction in a bracket. And then we're going to multiply everything by the lowest common denominator. So here we've got 2x plus 1 over 3 equals 5. So I'm going to make both sides of that a fraction, just put 5 over 1, so I can really clearly see what's the lowest common denominator. And of course, the lowest common denominator of 3 and 1 is going to be 3. So I'm just going to write that off to the side for you. The lowest common denominator is 3. And now I'm going to take this equation. Whoop, you do not have to rewrite it necessarily. I just want to get a good amount of space here. And I'm going to multiply everything in each piece of the equation by that lowest common denominator. So I'm going to put brackets here and multiply by 3, and brackets here and multiply by 3. Now it is important that we're going to use those brackets. Now we can reduce. Remember that choosing the lowest common denominator to multiply by allows us to reduce and get rid of the fractions on the bottom. Here I have multiplying by 3 and dividing by 3, so it's just a 1 left on top. So I get 1 times 2x plus 1. Because it's a 1, I didn't really need to actually write the 1 there, but oftentimes it may not be a 1. You may have reduced and had a bigger number out front. Then we're going to multiply into my polynomial. So multiplying by 1, I get 2x plus 1, and 3 times 5 is 15. So using this method of multiplying by the lowest common denominator, we really do end up with a nice clean equation like the ones we solved quite early in this unit. I'm going to go through the steps and undo the plus 1 by subtracting 1 from both sides. I'm not showing it over there, but we all know that that's what's going on. And then 15 minus 1 is 14. And then I'm going to undo that multiplication. I have multiplying by 2, so I will divide by 2 on both sides and get an answer of x equals 7 as my final answer. The next example, moving on to B, this is another method, and it only works, so I really want to highlight this, in one specific case. If we have one fraction on each side of the equal sign. You can still do the multiply by the lowest common denominator method here. Absolutely you can. And maybe I will show that in both ways. But if we have two fractions equal to each other, so one fraction here, and an equal sign in between, then we can do what's called cross multiplication. And basically that's multiplying the two diagonal pieces of this fraction. So it's called cross multiplication because we're going to multiply kind of diagonally across that equal sign. We are not able to do this if we don't have a fraction and nothing else going on in our equation. So I'm going to multiply 4 times 3k plus 6. And of course, I need to put a bracket around that binomial. And then the other diagonal, I'm going to multiply 5 times 5k minus 3. Now I've gotten myself to a point where I can multiply out these binomials. So multiply the 4 into the one binomial, and I'll multiply 3 or 5 into the other binomial, and then solve the equation normally. So I've gotten rid of my fractions. That's what a lot of these strategies are doing. So 4 times 3k is 12k, 4 times 6 is plus 24, and then 5 times 5k is 25k, and 5 times negative 3 is negative 15. Going through the same strategies of moving the variable terms to one side, I'm going to undo this by minus 25k on both sides. So I have 12k minus 25k. And over here I have plus 24, so I'm going to have minus 24. So negative 15 minus 24. 12k take away 25k is negative 13k. Equals, that's negative 39. And then we're going to divide both sides by that coefficient, making sure we're really careful with our integer operations here. That will reduce 13, multiplying by negative 13 and dividing by negative 13 just leaves k. Negative 39 divided by negative 13 is 3. So that's how we would do that with the cross multiplication. A different strategy of doing this would be to multiply by the lowest common denominator. So multiplying by the lowest common denominator, that's going to work too. If we had 3k plus 6 over 5 equals 5k minus 3 over 4. What's my lowest common denominator here? What would that be? We can take a look, and obviously we'd look at the 5 and we'd look at the 4 and say the lowest common denominator there is 20. So you could take this side of the fraction and multiply it by 20, that side of the equation, and multiply the fraction on the other side by 20. Now we're going to do reducing. I'm multiplying by 20 but dividing by 5. So I'm going to reduce 20 and 5 and I'll be left with 4. And here I'm going to reduce 20 and 4 and be left with 5. So my last step here, my next step, pardon me, not last step, there's still quite a bit of work. We've got 4 times 3k plus 6 equals 5 times 5k minus 3. So see how that's the exact same thing that I had in the first line of the cross multiplying way. You just have one more step. So if you really like this multiply by the lowest common denominator, it'll always work. You don't have to learn or remember the trick of that cross multiplying, which only works in this one particular case. This multiply by the lowest common denominator is going to work every single time. So this rest of the solution would be the exact same as what we did on the left. In example C, what's new here? Here we have the we have fractions, but we also have brackets. So we're going to have to distribute, and there's a common mistake that I want to point out here. We have 8 minus 2/5 times this bracket, and then 3 over 7 times this other bracket. And at this point, we need to be careful. This says multiply. Remember BEDMAS, we've got multiplication, which is distributing. We have to do that before we subtract. So sometimes people get mixed up and want to do this stuff out front first. We have to do the multiplication, which is multiplying that binomial in here and here before we do the subtraction. So I'm going to go through and do that. I'm going to leave that 8 out front. Now, oftentimes when people are multiplying fractions, they have a harder time if they're not all fractions. So those whole numbers, I'm going to put them all over 1. Here we've got negative 2 times 25, and you could reduce as you go. 2 times 25 is 50 over 5, and negative times positive is plus. 2 times 10 is 20 over 5a equals, now here I'm going to multiply 3 times 14 is 42 over 7, and obviously these are going to reduce. If you can reduce this in one step, absolutely go for it. And then minus, this will be 63 over 7. So I didn't reduce here, but if you can reduce as you go, that's a good idea. Now, 8 minus 50 over 5 is just 10. 20 over 5 is just 4a. This is 6a minus 9. So we end up with a much nicer solution, and sometimes when you have fractions, you may multiply and get rid of the fractions all by itself. If we didn't, if we still had fractions here, we would do the multiply by the LCD. But now we're all set to solve. So I'm going to keep the 4a that was here. I have a 6a, and I'm going to need to get rid of that by subtracting it from both sides, which will be negative on the left. Now I had negative 9 to start on the right-hand side. I had an 8, so I'll have to do minus 8 from both sides. I had a negative 10, so I'll have to do plus 10 on both sides. 4a minus 6a is negative 2a. Negative 9 minus 8 is negative 17, plus 10 is negative 7. Now that's okay. When we get to this part, you guys might be saying like, oh no, it's not going to divide evenly. Lots of times it won't divide evenly. That's okay. We're going to have a equals, remember negative over negative is positive, and I'm just going to leave that as 7 over 2. We're going to leave all of our answers as fractions unless it's a word problem. That's the time when you would round it to a decimal. So leave as a fraction, except word problems. So unless it's a word problem, you're going to leave your answer as a fraction. If it's a word problem, if the question is saying like, how many cans of paint do they need to paint the room? You're not going to say, I need 7 over 2 cans of paint. You'd say, I need 3.5. You would divide them to give kind of a decimal answer for any real life situation. So here, I'm going to again multiply out, distribute those monomials in front into my brackets before I try and deal with the fractions. This is my preferred way of doing this, but I'll look at another way and see if we can rewrite this to cross multiply. So I'm going to say 1/3 times 2 over 1 is 2 over 3x minus 5 over 3, multiplying the tops together and bottoms together. And then 3/4 times x, so 3 over 4 times 1 is 3 over 4x, minus, and this is 2 over 1, so I'm going to make that 6 minus 6 over 4. If you reduce that right away to 3 over 2, that's great. Now I need to eliminate my fraction, so I'm going to multiply by the lowest common denominator, which, looking at my denominators of 3 and 4, the lowest common denominator here is 12. So I'm going to multiply each term by 12. So you don't have to color code this, but I kind of like to do it this way. So I'm going to keep 2 over 3x and then minus, and then I'm going to multiply a 12 around that 5/3. And then I've got 3 over 4x minus 6 over 4. So I'm going through and I'm multiplying each piece, each individual term in this by 12, which is my lowest common denominator. Before I actually multiply this in, I'm going to reduce. So 12 and 3 reduces and I have a 4. 12 and 3 reduces here and I get a 4. 12 and 4 reduces and I get a 3, and 12 and 4 reduces to a 3. Now this next step, you don't have to write it out, but I find it's sometimes nice to kind of maybe worth it. So especially if you've written your previous step a little bit messy or you've kind of squashed stuff in, I like to write that out just so I'm really clear on what pieces are multiplying together. So now 4 times 2x is 8x, minus 4 times 5 minus 20 equals 9x minus 18. Now going through, remember x is to the left, numbers to the right. I've got 8x minus 9x equals negative 18, and then the negative 20 will be plus 20. 8 minus 9 is negative 1x equals 2. And then I'm going to divide out by negative 1 to get x equals negative 2. Now the question here says, can you rewrite this and use cross multiplication? And you can, for sure. If we wanted to rewrite the original with as 1 times 2x minus 5 over 3 equals 3 times x minus 2 over 4. And then we could do 2x minus 5 over 3 equals, and this one would have to distribute in there. So we get 3x minus 6 over 4. So then you could cross multiply from here and you would get the same answer as we got doing it the other way. So I'm going to say dot, 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 keep going there. Then you would cross multiply. Okay. So different ways of solving these, as long as you're showing your steps and following correct math and being clear with what you're doing in each step, there's lots of different ways of doing these. Some people maybe don't want to multiply by the LCD and maybe they just want to get a common denominator and solve this. That works totally fine as well. I find that this is the most popular way, so that's the way I usually show in my examples. Okay. So this one, 3p over 4 plus p minus 5 over 3 equals 1/2. And I would probably ask, can we cross multiply? Remember, what was the rule for what we needed to cross multiply? We needed a fraction equal a fraction. But is that what we have here? We've got equals a fraction, but we have two fractions added up. So we need one fraction equal to one other fraction. We can't do it here because there's two fractions added. It would have to be like that we could cross multiply, but when we have that extra term, now we can't. So this is going to be one where we have to multiply by the lowest common denominator. And I would always write that out to the side. What am I doing? What's my lowest common denominator? And that would be for 4, 3, and 2, my lowest common denominator is 12. So I'm going to multiply each term here by 12. And some of you may want to do something like this, and it's actually fine if you do, if you've written your question out big enough, if you have enough space. Sometimes people write teeny tiny little writing and then try and cram in like a times 12 in front of each thing, and it can be really hard to read and really hard to follow, and you may lose some of the pieces. You may miss a sign, or you may miss a number from when you've reduced. But if you've got enough space and if you kind of see a fraction coming, you may start to learn to just write out the question with a bit more space and write it a bit bigger so that you can squish that times 12 in right on your question, which is fine. So now I'm going to look at the reducing. 12 over 4, I have a times 12 and divided by 4, so that reduces to a 3. Here I have times 12 and divide by 3. So 12 and 3 reduce and there's a 4. And 12 and 2 reduce to a 6. And notice that we have to pick the common denominator because then they will all reduce. If you picked, say, times 15, you couldn't reduce that with the 4. You need to pick that common denominator so that you have a number that works. Now here, especially when you've got a binomial, I would very strongly recommend, I'm not going to try and multiply these in. I'm going to rewrite this. Plus 4 times p minus 5 equals 6 times 1. So I've gotten rid of all the denominators, but I'm rewriting my numerators with those new green numbers out front. And the reason is that I have this binomial. A lot of people, if they don't write this step, will forget to distribute that 4 into both pieces in the numerator there. That's a really important common mistake to make. So 3 times 3p is 9p plus 4 times p, 4 times negative 5 is minus 20 equals 6. So we're going to go through here. 9p plus 4p equals 6, and I'm adding 20 to both sides to move that. 13p equals 26, and then we'll divide by 13 to undo that multiplication, and we get p equals 2. So that's my final answer. The number one mistake people make in this kind is forgetting to distribute that 4. So be super, super careful if you have a binomial in the numerator. Make sure you write that extra step and remember to distribute that. So a few different word problems here with dealing with perimeter. A backyard has a perimeter of 144 meters. If the backyard is a square, what are the dimensions? I always like to draw a diagram. So I'm going to draw a square, kind of, sort of, and I may say S for the side of the square. I want to figure out this dimension using algebra, using solving equations. So I would know 4 S's, or 4 times S, equals 144. And to solve this equation, I just divide by 4 on each side. So I get S equals 36 meters. Pretty straightforward. For B, it says the backyard is rectangular. And now it says the length is 3 times the width. So I'm going to label a W there, but here I'm going to put 3W. So the width times 3 gives me how long the length is. So now my perimeter would be 2 times the length, which is 3W, plus 2 times the width, and that's also going to be 144. So you could also say 3W plus W plus 3W plus W, just to add them all up. So here for the lengths I get 6W plus 2W equals 144, and 8W equals 144. And when we divide this, switch colors here, we are going to divide by 8 and we get 18. So W is 18 meters. So here, the side length was 36 meters for the square. Now we would have 18 meters, and then the length there, multiplying that 18 times 3, this would be 54 meters. So 3 times the 18 gives me a length of 54. So these backyards both have the same perimeter. One backyard is 18 meters by 54 meters, and one backyard is a square that's 36 and 36 meters. The last one is a kind of funny shaped backyard. It's a triangle, and we have these dimensions. So we've got x, and this one, x minus 2 over 3. So we are still going with our total perimeter of 144. So let's add these up. If I have x plus x minus 2 over 3, I'm going to make that equal to 144. To make this a little bit nicer before I deal with the fraction, I'm going to add x plus x because we know that that's 2x. Now I'm going to look at the lowest common denominator because I want to solve for x. I'm putting ones on the bottom just to kind of show what the denominator would be, but my lowest common denominator here is 3. So I'm going to multiply a 3 out front of each of those terms in my equation. So I would reduce, careful here, we need to reduce before you multiply. Multiply by 3 times 3, or divide by 3, is just 1. So I get 3 times 2x plus 1 now, because it reduces, times x minus 2 equals 3 times 144. And we'll keep on going to figure this out. We get 6x plus x minus 2 equals 144 times 3 is 432. Now here, adding these up, we get 7x equals, and I'm going to take the negative 2 and add 2 to both sides. So 7x equals 434. If I divide by 7 on both sides, here I would have x equals 62 meters. So the two sides of the triangle here are going to be 62 and 62 meters. Now we could figure this out, and kind of this is a good chance to double check our work. So we could say kind of off to the side here, I know I need to do x minus 2 divided by 3. So 62 minus 2 divided by 3, 60 divided by 3, which is 20. And we could check this. We know it should add to 144. So check 62 plus 20 equals 144. So that's a good way of checking that we've done the equation correctly in this question. So the last one, this is a really good thinking question. It says, which has the biggest area? Now that's not too hard for the first two, but we are going to have to take a little bit of a critical look at this for the last one, for the triangular one. So just to remember, we've got a square. These all had the exact same perimeter. We had a square which had 36 meter sides. Then we had a rectangle, which was 18 meters by 54 meters. Then we had a triangle, which is, goodness, not to scale here. We had 62, 62, and 20. So, area here, pretty straightforward. It's 36 times 36. 36 times 36 is 1,296, and that's in meters squared. Do you think this one will be bigger or smaller? Let's try. It has the same perimeter. So here, area is 18 times 54. So each of these we're using, I should write this out, length times width, or length squared. for a square. So length times width, of course, for area of a square or rectangle. Here it's much smaller. We get 972 meters squared. So if you have the same amount of perimeter, you're going to get more area from a square shape than from a rectangle shape. Let's see about this triangle shape. What's the formula for area of a triangle? You might say, hopefully, it's 1/2 base times height, or base times height divided by 2. So we know the base. The base is 20. What's the height? How could we figure that out? Height, remember, is straight down through the middle. So this is a little bit of review from what you guys would have seen. If that's height, that's 62. What was the rule that we've looked at in grade 8? For sure, you guys do a lot of this to find a missing side in a triangle. Do you remember a squared plus b squared equals c squared? Pythagorean theorem. Now, what would this side be here? We're looking at just this half of a triangle, aren't we? So that's going to be not the whole 20. I'm going to use a 10. So using Pythagorean theorem here, the two shorter sides are the h and the 10. So h squared plus 10 squared equals 62 squared. And then I'm going to go through, h squared plus 100. I do not know what 62 squared is, but good thing I have a calculator. 3,844. And then h squared, I'm going to subtract 100 from each side. $3,744. And then to solve for h, we need to do the square root. So h is about 61.19 meters. So now we can use this to find the area. So the area is 1/2 times the base, which is 20, times the height, which is 61.19. So we get 611.9 meters squared. So this one ended up with the smallest area of all in the triangle. So if you need to review Pythagorean theorem, that might be a good idea. But in general, what we want to be able to do is what we were doing back here, setting up different equations and being able to solve them given information about a geometric figure. That's it. We are moving on to the last couple days of problem solving with equations in the next lesson.